Today we'll be talking about the rectangular and parametric forms of conic sections, okay? So the general equation, and we've seen glimpses of this in the past couple of videos, but in this video you actually see the whole thing for all its nasty glory. Okay, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where a, b, and c are not 0. Now the others could be 0, it doesn't matter. If a, b, and c are 0, then we're dealing with a special kind of conic, and not all three of them are going to be equal to 0. Okay, now how do I identify by just looking at the equation? All right, for circles, if a equals c, it's a circle. For parabolas, either a or c is 0, so either this is 0 or this is 0. For an ellipse, a and c have the same sign, and a does not equal 0. Okay, so that's pretty simple. For a hyperbola, a and c have opposite signs, or a equals c equals d equals e, which equals 0, which is the rectangular hyperbola that you've learned about before, the x, y equals k. Okay, and that's the situation where that happens. Alright, so let's take a look at some example problems with that. Alright, so some things to look at in here. Obviously we have both a and c right here. So let's take a look at some of the rules. Okay, so for circles, a equals c. Well, obviously this is not equal, so this is not a circle. Okay, so what you can do is use process of elimination to kind of rule it down. So it's definitely not a circle. Okay, for parabolas, either a or c is 0. Well, those are definitely not zeros, so it's definitely not a parabola. Okay, so this is kind of nice. We're just eliminating, we've at least eliminated 2 of them. For ellipse, a and c have the same sign, and a does not equal 0. Well, a does not, oh geez, I've been reading this backwards. Look at this. This is a, and this is c. Okay, but still doesn't matter, doesn't follow the same rules. Okay, all right. However, they do not have the same sign. Okay, so it is not a ellipse. Okay. Now some of you guys are probably going, oh, it must be a hyperbola. Okay, for a, go back and check the rules, because it could be not a conic at all. So just, you have to be very careful when working with this. So for hyperbola, a and c have opposite signs. If you notice, a is negative, c is positive, voila, it must be hyperbola. Hyperbola, as some students would say. Okay, so you just have to eliminate all the possibilities and then check to see if it's that fourth one. Okay, now on this one, as you can see, a and c are both the same sign, so this is a circle. I don't even need to rule out the other ones. Okay, so that's as simple as it is in identifying rectangular conics. Okay, all right. Now, general form for a set of parametric equations. Remember that f equals a function of time, and y equals another function of time, where t is in some interval I. Okay. Now, what we're going to talk about is we're going to talk about taking a parametric equation and turning it into a conic. Okay, so now if you notice right here, it's all set up nice and neat parametrically. But if we wanted to write it conically, what you could do is you could actually graph this with your table with t, x, and y, and just graph like that. I like to just do it algebraically. Okay, so I'm going to notice, okay, this is the easiest one to kind of get there. So what I'm going to do is to get rid of that, I'm going to solve for t, because I want to do substitution. So I'm going to square both sides, and so what I get is y squared equals t. Okay, oops, no v in there. Okay, now all I'm going to do is replace this t with y squared, and I get x equals 2y squared minus 1. Okay, and as you can see, this is definitely going to be a parabola. Okay, right? Now, it's probably going to be a parabola, and you can graph it on Desmos and just check it out, but it's probably going to be centered about the origin. So this is at the origin. Well, actually, no, it's centered about, let me see, the vertex is going to be 0, comma 1. Oh, negative 1. Gotta remember, this is in vertex form. Okay, and the focus is definitely going to be let me see. So since it's y squared, it's going to be a horizontal parabola, which is new. So we'll be adding plus 0. So it's going to be 0 plus or minus p, comma, negative 1. Oh, no, it's actually going to be minus. Jeez, I'm slipping my old age. I keep getting the two sets of rules screwed up. Okay, so it's going to be 0 minus p. Now, if you remember p, we need p, so we're going to use this formula, 1 divided by 4a. Well, in this case, 4a is 2, so 4 times 2 becomes 8. So this becomes 1/8. So this actually becomes negative 1/8, comma, negative 1. And that's the focus. And if I wanted the directrix, okay, the directrix would actually be... Okay, and I just realized I made a mistake on here, so let me go back and correct that. So that's going to be plus p, so this should turn into a positive 1/8. Okay, so 1/8 right there. Alright, now the directrix is going to be the opposite, so it's going to be 0 minus p, so the directrix is going to be x equals negative 1/8 as the line. Okay, and if you graph it, you should be able to see it, and it works out pretty nicely. But just remember, you're going to be replacing some of this you're going to be replacing some of these t's with letters, so try to solve for the easiest one. Now, I could have technically plugged this in, but that really would have been a nice looking parametric, whereas if I just squared the y, I knew I'd probably be dealing with a parabola because just y is squared in solving for t. So try to solve for the easiest one first and just work your way across till you get an actual conic. Okay. Alright, now sometimes you might have to do some parametrics with some trig functions, such as this. Okay. Now on this one, what we would do is we would divide both sides by 2. So x divided by 2. And what we're going to try to do is get this equal to a identity. Okay, and so this one's going to be y divided by 2 equals sine of t. Okay. Now, if we kind of set it up, this is going to be kind of neat to actually work with. Okay. We're going to use the identity cosine squared of t plus sine squared of t equals 1. Okay, well, if you notice, cosine and sine are actually equal to x divided by 2 and y divided by 2. So I can quickly replace those with x squared divided by 4 plus y squared divided by 4 equals 1. Okay? Now that's pretty neat, nice and neat. Now if you notice, if I times everything by 4, I'm going to get x squared plus y squared equals 4. And it's a circle with a radius of 2 centered at the origin. Okay, so that's some really cool stuff that you can do with turning parametric equations into it. But you do need to know your trig identities big time, because if you can replace your trig identities with some of this stuff that you start with, and you're like going, oh, I don't know where to go from here. How do I do sine inverse? But if you remember your Pythagorean identities and some of your special identities, you should be able to work through this pretty easily in turning parametrics into actual rectangular coordinates for conics. Okay? Alright, that's it for working with pre-calculus with talking about rectangular and parametric equations for conics. I'll talk to you later. Bye.